Welcome to Get Your FRQ On. This question is from 2024. It's question 4, and it is not calculator active. In the question stem, we have the graph of a piecewise function, and we're told a little bit of information about it, but we don't actually have the definition in terms of functions, what that piecewise function is. In part A of the question, we define a function g of x to be the integral from 0 to x of f of t dt. The graph f is the graph shown in the question stem. And we are asked to find g of -6, g of 4, and g of +6. So g of -6 would just be the integral from 0 to -6 of f of t dt. And we're given in the question stem that the area of that region is 12, but notice that our bounds are backwards. Our upper bound is lower than our lower bound. So the integral from 0 to -6 of f of t dt is the same as the opposite of the integral from -6 to 0 of f of t dt. And we're given in the question stem that that integral is 12. So this integral is -12. So g of -6 is -12. G of 4 is simply the area under the curve from 0 to 4. This shape is just a triangle, so you can just use the formula for the area of a triangle to calculate that area. It turns out that that area is 4. And g of 6 is the integral from 0 to +6 of f of t dt, which is really just the sum of two areas of triangles, where one of them is underneath the x-axis. And we get 4 minus 1, which is 3, so g of 6 is equal to 3. In part B of the question, we are asked to find all critical points of g of x on the closed interval from 0 to 6, and to give a reason. So the function g of x will have a critical point when its derivative is 0. Given the definition of g of x as the integral from 0 to x of f of t dt, g prime of x is just f of x. And so really what we're after here is, when is f of x equal to 0? Well, on the interval from 0 to 6, f of x equals 0 only once, and that is at x equals 4. So g of x is a critical point only at x equals 4, and we know this because this is the only x-intercept of f of x on the interval from 0 to 6, indicating that g prime of x is 0 there and also changes sign. In part C of the question, we define h of x to be the function, the integral from -6 to x of f prime of t dt. And we are asked to find h of 6, h prime of 6, and h double prime of 6, and to show our work. All right, so h of 6 would just be the integral from -6 to 6 of f prime of t dt, which is just f of 6 minus f of -6. Notice the use of the Fundamental Theorem of Calculus here. F of 6 we get from the graph, f of 6 is -1. F of -6 we get from the graph, f of -6 is -1/2. So f of -6 is +1/2. F of 6 minus f of -6 is -1 minus 1/2, which is -3/2. H prime of 6, by definition, would just be f prime of 6, which is just the slope of the graph at 6, which is -1/2. And h double prime of 6 would be f double prime of 6, which in this case would be 0 because f prime of x is constant over this interval, so derivative of a constant is 0. All right. Don't forget to like and subscribe to my channel if you appreciate the work we do here at Get Your FRQ On. Thanks for joining us.